everyone. It is my absolute privilege to welcome Stephen Flain, who is Head of Developer Relations at Chainlink Labs, all the way from Minnesota in the US of A at the moment. Stephen, welcome to a South African audience. We're looking forward to hearing what Chainlink are up to at the moment. The big news, of course, is what you are now bringing to this NFT space. Of course, Chainlink always been a groundbreaking platform and blockchain, and now to be able to bring a new side and aspect of what NFTs can offer this space is really exciting. So without further ado, ladies and gentlemen, please welcome Stephen Flain.
Thank you so much. I'm really happy to be here. This is going to be a lot of fun, I think. So today we're talking about the next generation of NFTs, which are, from our perspective, dynamic NFTs or Oracle-powered NFTs. So if you've never heard of Chainlink before, Chainlink is a platform for building decentralized Oracle networks, which really connect smart contracts and the decentralized applications that you're building to the real world. And so we're going to talk a lot about that and how it can empower NFTs. Back in 2016, I was fortunate enough to visit Paris and to visit the Louvre. And in a small room in the Louvre, you have this kind of amazing space with lots of art. But on one wall, there is the Mona Lisa, and it's sitting there. And I looked at it for a moment, but then I kind of took a step back. And what I saw was hundreds of people crowding around this tiny, tiny piece of art, just kind of to experience it, to see it, to be a part of it. And this was really interesting to me because it's a very different way of consuming art. And what I think is that this actually is a really good metaphor for what we're seeing with NFTs today, where there's a lot of people that are really excited about NFTs. The space is growing. There's a ton of attention, and everyone's kind of crowding to find what's next. And so that's really the goal of today's talk, is to give you a backdoor entrance into showing you what the future of NFTs are going to be from our perspective and how you can kind of be a part of this. So as was mentioned, my name is Stephen Fluin. I am the head of developer relations for Chainlink Labs, working on Chainlink. And really what I focus on is combining an understanding of what businesses are trying to achieve and how to use technology to make you successful. And I really believe that blockchain is at the center of all of this, right? If we can build great decentralized applications, we're going to be empowering the world, building a more equitable, more fair world for everyone. And this is really essential to a lot of the work that we do at Chainlink Labs. I'm going to go through this talk in 3 parts. First, we'll do a little history lesson with a bit about the past, the present, and talk a little bit about the future of NFTs. Then let's actually go ahead and build a dynamic NFT. And then let's talk a little bit about the use cases and kind of what you should be doing at home or wherever you are and trying to build the next generation of NFTs. So let's dive in. So let's start off talking a little bit about the past. And so one of the things I think is very, very helpful is if we're all on the same page around what an NFT is and kind of how it works. And so I want to actually dive into the terms a little bit. So NFT stands for non-fungible token, but a lot of people don't even know what a fungible token is. So I want to introduce this concept. So way back in 2009, the concept of a fungible token, very, very popular. It wasn't really called that, but that's effectively what it was. And so just to give a really quick example of how this worked, let's imagine I had 1,000 of these tokens of some sort, and I gave you 500 of these fungible tokens. And then I made a purchase from you, or I consumed some of your goods or services, or you consume my goods or services, and you sent those 500 fungible tokens back to me. So now I have 1,000 tokens and you have none, but you can't actually look at my pile of tokens there and figure out which ones were the ones that you were holding and which ones were the ones that I was holding, right? You cannot distinguish them. They're all identical and they're all fungible. This is the concept behind fungible tokens, is you can't really tell them apart. So there's lots of examples of this. So Bitcoin is a fungible token. Ethereum has a fungible token. Chainlink is powered by Link, which is a fungible token. And there's thousands and thousands more of these. They're very, very popular. So now let's add in the non-fungible token piece of this. So this was actually something that was kind of more canonicalized in 2012 is when I think the term was started to be used. Or there was examples on Bitcoin where tokens could be differentiated from each other. And so they were no longer fungible. And so you can think about this is, let me give you a piece of art, and now there's no way for you to divide that piece of art, give part of it back to me. And if you give it back to me, I would be able to say, this is the piece of art that I gave you, right? Like we can tell all of these things apart. And that's how NFTs work. Is it's a token that you can distinguish from other things. One of the important things to understand about NFTs is that they tend to represent something. So this can be something in the arts, like a painting or a picture. This can be something collectible. So this is very popular in gaming, where maybe you achieve something, you get a badge that represents that you've achieved that, and it's something that you can hold on to. It's unique to you. But NFTs can also represent things like physical assets or even digital assets. I heard a great example earlier of tickets. So tons and tons of examples. I think one of the most popular ones that we've heard about or really kicked things off was CryptoKitties, so cat pictures, but also there's CryptoPunks, there's tickets, as we mentioned. There's lots of really cool concepts around, like, for example, what if you could represent a mortgage with an NFT? And so when someone purchases a home from you, you transfer the mortgage, and the mortgage is powered by smart contracts. I think that's really cool. We've seen very popular examples where tweets end up being a NFT. Badges are very popular. So when you attend an event, a lot of events are giving out things like NFT badges. You can even think of them as like trading cards, where you can have your favorite sports players, all these sorts of things represented as an NFT. So NFTs were they existed, but they were really formalized into a really useful standard back in around 2018 as part of EIP 721, the non-fungible token standard. And what this really did is this leveled up the industry so that instead of having a bunch of different implementations of what an NFT is and how it works, now we have a standard. And anyone that follows that standard is going to be able to benefit from standardized tooling, standardized marketplaces, all those sorts of things, right? We see things like OpenSea, which is a marketplace where it's very easy to sell, trade, collect all of your NFTs. And this standard was a huge part of that back in 2018. But if you look across the industry today at NFTs, they're hugely popular. There's billions of dollars being spent on these sorts of things. But for the most part, they're relatively static. When you buy an NFT, it doesn't change over time. It just is fixed in place. And so if we look at the future, things are going to be a little bit different. Obviously, we're going to end up seeing lots and lots more growth. NFTs don't seem to be slowing down in terms of the number of people using them. We're going to see them for more use cases, and I think hopefully more valuable use cases where it's not just a piece of art or culture, but maybe it's something that actually represents something that is needs contracts, needs digital agreements, needs trustless systems in order to operate. I think we're going to see NFTs maturing a lot. And the biggest thing, and what I'm really here to talk about, is the idea of these NFTs becoming dynamic in nature so that they can change over time. So if we got to a world where instead of NFTs being static, they could actually react to the world, that's what oracles can do. And so if you think about your trading card game or your collectible, what if you could integrate with a decentralized oracle network like Chainlink and then access real world information and react to real world information so that your NFT lives and breathes in the same way that the rest of the world does? This is what's really, really exciting about the future of oracle-powered NFTs. So in order to actually demonstrate how easy this is, I want to actually go ahead and build one of these. So keep in mind that any live coding is subject to things going terribly wrong. So please bear with me if there's any curses placed on this demo today. But effectively what we're going to do is we're going to start with just a simple NFT smart contract. And then I'm going to make that NFT dynamic by connecting it to one of the Chainlink products called Chainlink Keepers. Chainlink Keepers, if you've never heard of it, is basically an automation and off-chain compute tool. So what you can do is you can set up a contract that a keeper is executing and checking the conditions of that contract. And when the conditions are right on that contract, something happens on chain in order to update, evolve that. So this could be checking weather data. This could be checking real world stats. You could build timer. There's lots of different examples of these, which I'll go through first a little bit later. But let's now dive into this demo. So what I'm going to do is I'm going to go to Remix. So this is a very popular web-based IDE for building smart contracts. And I'm just going to paste in, just to start us off, a very simple smart contract. So let's go ahead and make a new file, and we'll just call this mynft.sol. So I'll just walk through this very, very briefly. This is just standard Solidity code. And what you're going to see is we're creating a trading card. We've pulled in a couple tools from OpenZeppelin. And then we're setting up that trading card to be called the Stephen Fluin trading card, or the SFTC. It's only the owner, only the person that deploys this contract is going to be able to mint new versions of these NFTs. They're going to have incremental numbering. So first you'll have NFT number 1, then number 2, and so on. And then one of the things that, for example, OpenSea looks at is this idea of a token URI. And so that's the URL on the web that represents the thing that the token is connected to. And so if we take this example contract, what we can actually do is we can go ahead and deploy this. So we'll just jump over to the deploy feature here. And let's go ahead and put it actually on the real blockchain. So I'm going to use Rinkeby right now. And we're going to go ahead and pick the contract, the trading card, and I'm going to hit deploy. So I'm going to confirm this transaction on chain. And what we should get out as soon as that is confirmed by the network is an actual trading card. So now our NFT exists on the blockchain, but right now there aren't any actual instances of that NFT. So what we're going to do is I'm just going to paste in an address here and a URL, and we're going to call the mint item. So again, we're going to put that transaction on the blockchain. And what we should be able to do now is actually copy this address and go to the OpenSea website. And you'll see that when I click submit, this sometimes takes a little bit of time just because blockchains and propagation and caching and things like that. But it looks like the contract has confirmed. So hopefully we can submit this soon. If not, I'll just walk through it. Okay, there, we've submitted it. And we can see that there's one item. This will all load very, very shortly. But effectively what we've got here is an NFT of an image of me a long, long time ago. So this is me when I was in high school, super geeky, super embarrassing photo. But this was the first version of my rookie card of the Stephen Fluin trading card. And you can see we've actually got a series of these images where I'm kind of leveling up in my life. So then I got a job. I learned how to wear a suit. And then I started traveling the world, presenting at conferences, helping developers on the Angular team at Google. Then I had a couple kids, and then you've got me today. So we're going to actually have this trading card. We want it to be more dynamic. We want it to be Oracle powered. And so we're going to level it up now by taking that same contract, and we're going to add in keepers. And so if we take a look at the one item, yeah, we can see here the image just hasn't loaded yet, but that should come in a little bit. All right, so let's jump back to our contract. And so we're going to make a bunch of different changes to this contract in order to make it dynamic. And so let's just dive into the code. So the first thing I want to do is I'm going to switch over to Coven so that we can power this via the Keeper network. And then what I'm going to do is I'm going to actually build in a counter. So I'm just going to represent this idea that we're leveling up from 0 up to 4. And so what I'll do is I'm going to create a mapping of uint 256s to uint 64s, just for a small counter. And we'll call this counters. And so what that will do is it'll allow us to have every NFT that we mint have its own little counter. Then what we're going to do is we're going to go down into this token URI. This is where we determine the path for that metadata. And instead of just returning the metadata that exists on the chain or on the token that we minted, what we're actually going to do is we're going to make a new string. So we're going to just abi.encode here. And we're going to give it both that string that was encoded as part of the minting. And then we're going to do strings.toString. We're going to pass in the counter. And just for now, I'm going to just give it the array 1 or the key 1. And then we're going to say .json at the end so that we're going to be pointing at JSON files here. And we're probably needing an extra parenthesis here. 2 more parentheses. Perfect. All right. So now what we've done is we've told it when you create this NFT, a URL that's going to take in both the token ID as well as what was established as part of creating that token and the counter on that token. And so what we can do now is we can actually hook this up to a system, a keeper, that is going to maintain that and actually update that counter for us. So we're going to need a couple things for that. So we're going to need to make an interval. So this will just be a uint. And then what we're going to say is that interval, we're just going to set it to 30 seconds. And then what we're going to do is we're going to create a last timestamp. And that's going to be another uint. And what this will do is this will just make sure that we're not checking, or we're not trying to update our smart contract every block. We want to just do it at most every 30 seconds. And now there's kind of 2 magical methods. Counters. Thank you. And so there's 2 magical methods that we're going to need to implement to interact with the Keeper network. The first is something called checkUpkeep. And so we're going to create this new method as a function, and it's going to take in something called a check data. And what check data is effectively when you set up your keeper, you can choose to pass in arbitrary data into the smart contract. We're just not going to use that in this example. We're going to try and keep it simple. And we're going to return a bool called upkeep needed. So what's actually very cool is check upkeep runs off chain. It's simulated by the keeper. And so it doesn't actually cost any gas to check upkeep. You can run it every block. You can run it as often as you want to. but what happens is this method, this function gets called, and then if upkeep needed is true, then it's going to do the on-chain transaction. So, and then the other thing we need is the perform data. And this is the data that's going to be passed to the actual function that executes on chain. So our simple check upkeep function, basically we just want to do it based on time. So what I'll do is I'll say upkeep needed is equal to the block.timestamp minus last timestamp, and we're only going to execute if that is greater than interval. If it's been 30 seconds, then we're willing to perform another upkeep on chain. And then just to keep things within bounds, I'm going to say our counter has to be less than 4. All right, so that's upkeep needed. And then what we need to do is we need to set perform data, and we'll just pass the check data all the way through because we're not actually using it in this example. Looks like we've got a typo. Yep, counters. There we go. And now we're going to add the second function. So this is what actually executes on chain only if check upkeep returns true. And so this is going to be a function called perform upkeep. And this is going to take, again, bytes, call data, perform data. So this is any data that you calculated off chain as part of the simulation. You can actually pass that on chain and benefit from all that computation from that was happening off chain. So this is going to be an external method. And then we're going to set the counters. Let's hard code it again for now to the first NFT, and then we'll add 1 to it, and then we'll update the timestamp so it doesn't run too often. All right, so effectively what we've done is we've now taken that NFT that was working great, and we've wired it into the Chainlink Keeper network so that it can be maintained and kept up to date over time. And so let's go ahead and deploy this and give it a try. And actually, let's do a quick test here by the injected Web3. So we'll select our NFT again. We'll deploy it. Actually, whoops. I want to do it in the VM first. So let's go ahead and deploy that. And we'll go ahead and mint one of these. And so I'm just pasting in the address and then the URL prefix. And then what we should be able to do is actually take a look at the token URI for token number 1, because we minted it. It's 0.json, which corresponds with this image. And then what we can see is every time our upkeep runs, which we can simulate just by running perform upkeep, the URL should update. Now we're at 1.json. And so we can actually deploy this on chain now that we've tested it. We'll just go ahead and do that. And then we'll take whatever address we're given here, and we'll jump over to the Keepers app. And we'll just say register new upkeep. I'll just put in my email address. Upkeep NFT. So we'll just paste in that address, give it a gas limit, and give it a bunch of link to fund it. So we'll go ahead and register that, pass it in some link. And what we should see is that as soon as this smart contract starts, the registration is done with the Keeper will automatically update it. And we should see that this contract, one thing we forgot to do is actually mint the contract here, or the NFT. Let's go ahead and do that. But now what we should be seeing is that our token URI should be, for token number 1, is 0. And then as soon as the NFT or the Keeper executes, we'll see that down in this list, and it will actually increment that number, and our NFT will evolve over time among all the different variations of the Steven trading card. So I'm going to jump out of the demo here and just kind of go through a couple things. So we did it. We were successful. Hooray. There's limitless use cases for Oracle-powered NFTs that are more dynamic and capable in their many different ways. So there's all sorts of things you can do. So we just did a simple timer here. You could base this on market conditions based on what price feeds are. You could do it based on human achievements, digital agreements, many, many more. And these are all powered by a bunch of different capabilities that Chainlink has, everything from getting randomness from VRF, automation with keepers like we saw today, the data feeds. You can get any custom data you want via any API capability of using your Oracle to hit any API web backend. And then you've got cross-chain coming soon, which is very, very exciting as well. So a couple quick examples of this is someone built a weather NFT. So the NFT evolves and is dynamic and changes based on the weather data coming from a decentralized Oracle network. You've also may have heard of LaMelo Ball. He actually shipped an NFT where the NFT evolved based on the stats and what actually happened in his career, which is a really, really fantastic use case. So my hope for you, having heard this presentation, is that you understand the power of dynamic Oracle-powered NFTs. and you're going to take this and level up what's possible with your NFTs. If you're interested in this, we actually, on October 22nd, we started a Chainlink hackathon. Definitely go to hack.chain.link to check it out. Build something. We got over $500,000 in prizes. We've got thousands of people participating. It's a very, very exciting hackathon. And hopefully you will come with us on this amazing journey. Thank you so much, everyone.